session. So today we're going to talk about lines in the space. The objectives, writing equation of line, equation of a line in the space. This is our objective today. We're going to learn how to write equation of line in three-dimensional space. Recall that in algebra, you learn to write equation of a line in 2D. Suppose you have a two-dimensional space, x-axis and y-axis. To write equation of a line, any line like L, we need 1 point on the line and the slope of the line, or the direction of the line. To write equation of L in the plane or 2D, two-dimensional space, we need 1 point. 1 point, okay. Suppose you have a point like P, x sub 0, y sub 0. And also the slope of the line. And the slope or the direction of the line. Then you say that, hey, y minus y sub 0 is equal to m times x minus x sub 0. This is a 2D version. I expect you to ask, hey, now that we talked about the three-dimensional space, how do you write equation of that line in 3D? So this is our question. How to write equation of a line like L in the space. In the space or three-dimensional space. Okay. So step by step, we're going to use the vectors and the vectors operation and write equation of a line in the space. Well, suppose this is your x-axis, this is your y-axis, and this guy is your z-axis. You have a line in the space. This is your line, L, and it is parallel to a non-vector like V. You have a non-vector like V with components A, B, and C. Note that to show that I have a vector, I'm not using parentheses. I'm using vector symbol. And I also put a bar on top of V. So suppose L is a line in the space. And we know it is parallel to a known vector like V, A, B, C. What are we going to do? We're going to take 1 point on the line. Let P sub 0 with coordinates x sub 0, y sub 0, z sub 0 be 1 point on the line. So P sub 0, x sub 0, y sub 0, z sub 0 be a point on the line. Well, since I have a point in the space, I can easily create a vector. What is the vector? This is a vector. A vector R sub 0 that connects the origin to point P. R sub 0. So I have R sub 0 connecting the origin to this point on the line. P sub 0, X sub 0, Y sub 0, and Z sub 0. This is my first vector. We're going to take a second point on the line. Let P with coordinates X, Y, and Z, the general coordinates. X, Y, Z with a second point on the line. X, Y, Z. Be another point on the line. Again, since I have another point in the line, I can quickly form a vector. This is my second vector. Using the points on the line. R is going to be your vector that connects the origin to your point on the line. So this is my second vector here, R, that connects the origin to point P, X, Y, and Z. Okay, perfect. I expect you to ask, hey, Professor, now that you have 2 points on the line, you can connect these 2 points and create a new vector, and you see the sum of R sub 0. And that vector is nothing but vector R. So we are constructing a relation between 3 vectors, which is the sum of 2 vectors equals to the larger vector R. So let us call this guy vector A. We can form vector A, which is R sub 0, R or P sub 0, P. P sub 0, P. Okay, perfect. This is my third vector related to this line. By sum or addition of 2 vectors, we can write it this way. R sub 0 plus vector A is equal to vector R. So far we have this relation between these 3 vectors. Or R sub 0 plus A is equal to there you go. So I think you to ask, you talked about this known vector V. How do we use that known vector V? Our vector A and vector V are actually parallel to each other. So you can write, since vector A is parallel to vector V, we can write, so this is the parallel sign, parallel notation. We can write vector A as T times vector V. And we can replace that here. So R sub 0 plus A, which is TV, is equal to vector R. So the vector equation of line L passing through the point P sub 0, X sub 0, Y sub 0, Z sub 0, and parallel to a known vector like V, we're using a symbol, vector symbol, A, comma B, comma C, can be written as R equals R sub 0 plus TV. Okay, R was vector X, Y, Z equals to R sub 0 is vector X sub 0, Y sub 0, Z sub 0 plus T. V has components A, B, and C. So this is the vector equation of line F. Of line. The rest is algebra. What are we going to do? We're going to distribute T and add the first components, the second components, and third components, and we're going to define the parametric equation of the line. X, comma Y, comma Z can be written as X sub 0, Y sub 0, Z sub 0 plus just distributing T, multiplying that by the rest of the components, TA, TB, and TC. Now, I'm going to add the first components, the second components, and the third components. So X, Y, Z can be written as X sub 0 plus T times A, Y sub 0, T times B, and Z sub 0 plus T times C. Okay, perfect. So what's the meaning of that? We have two vectors that are equal to each other. It means that X is equal to X sub 0 plus TA, Y is equal to Y sub 0 plus TB, and Z is equal to Z sub 0 plus TC. This system is called the parametric equation of the line. Okay, again, algebra. The first equation tells me that X minus X sub 0 is equal to T times A, or T is equal to X minus X sub 0 divided by A. The second equation tells me that Y minus Y sub 0 is equal to TB, or T is equal to Y minus Y sub 0 divided by B. And the last equation tells me that, hey, Z is equal to Z minus Z sub 0, let's do the subtraction here, is equal to T sub C, T times C So t is equal to z minus z sub 0 divided by c. T is equal to the first fraction, t is equal to the second fraction, t is equal to the third fraction. T is equal in all of them. So these fractions must be all the same. X minus x sub 0 over a is equal to y minus y sub 0 over b equals to z minus z sub 0 divided by c. This equation is called the symmetric equation of line F. Symmetric equation of line F. So we define three different equations. They are all equivalent to each other for line L in this case. An example. So let us list these equations on this side. Vector equation. R is equal to R sub 0 plus T times V. And then we learned about parametric equation. X is equal to x sub 0 plus AT, y is equal to y sub 0 plus BT, and C. Z is equal to Z sub 0 plus CT. Then we learned about symmetric equation. X minus x sub 0 over A is equal to y minus y sub 0 over B equals to Z minus Z sub 0 divided by C. Example. This example says, find a vector and parametric equation. Find a vector equation and a parametric equation of a line passes through point. So here you have a point 5, 1, 3, and it is parallel to vector and parallel to vector I plus 4j minus 2k. Okay. Our goal is to find a vector equation and a parametric equation. Vector equation and parametric equation. We know that when we write vector equation for the line, writing the parametric equation is not very hard. So let us start. To write vector equation of the line, we need 1 point on the line, 1 point on the line which is given to us. Five, 1, 3. When you have 1 point on the line, you can quickly write the vector associated to this point. The vector associated to this point is r sub 0. Now that we are writing a vector, we use a vector symbol, 5, 1, 3. So we found r sub 0, the vector. We also need a known vector v with components a, b, c. Okay. We know that our line is parallel to this known vector, which is vector v, with components 1, 4, and negative. So we have all the information that we need. We just need to follow the formula. Let us follow the formula. Formula says, hey, r is equal to r sub 0 plus tv. R, so what is r? Remember that r was the vector that represents a general point on the line. It was x, y, z equals. Vector r sub 0 is 5, 1, 3. T is just a parameter, it's just a variable, we need that variable, times the known vector v, 1, 4, minus. We can leave it as it is, or we can write it in nice and compact form. So x, y, and z can be written as 5 plus t, 1 plus 4t, and 3 minus 2t. This is our vector equation. After writing vector equations, parametric equation is super easy. X is equal to 5 plus t. Parametric equation is x equals to 5 plus t, y equals to 1 plus 4t, and z equals to 3 minus 2t. This is a parametric equation. So when we write the equation of the line this way, by plugging different values for parameter t, we can find some other points on the line. For example, if t is equal to 0, then by plugging 0 here, one point x, y, z on the line can be written as 5, and the second coordinate is 1, and the third coordinate is equal to 3. 5, 1, 3. The very first point that is given to us in this example. You might say, hey, t is equal to a half, t equals to negative 3/4, t is equal to square root of 2, anything that we want. We can plug in t to be a half, or 1, or negative 1, and find more points on the line. So this point x, y, z can be written as, okay, if t is equal to 1, you get 6. The second point is 5, and the third point is 1. These are some points on your line. By plugging different values for your t, you can find the rest of the points, more points on the line.